In this video, the topic to be covered is a protocol using go back N ARQ. A protocol using go back N ARQ, automatic repeat request. Generally, in the stop and wait flow control, it was assumed that the transmission time required for a frame to arrive at the receiver plus the transmission time for the acknowledgement to come back to the sender is negligible. Suppose this is the stop and wait flow control method. This is sender and receiver. Frame is sent. Some time to reach the receiver node. The acknowledgement is from receiver to source. This is the frame. This is the acknowledgement. In the stop and wait flow control, it was assumed that the transmission time required for a frame to arrive at the receiver, that frame is reached to receiver, plus the transmission time for the acknowledgement to come back to the sender is negligible, general way. But in some practical situation, this assumption is not correct. In some cases, this assumption is not correct. In this system, like satellite communications, the round trip time can be as long as 50 milliseconds propagation delay. Therefore, this will reduce the efficiency of the protocol. Suppose in satellite communication, this is the satellite communication. Satellite communications, round trip delay time is more. Propagation, this is the satellite earth station. This one is earth station, transmitting earth station, receiving earth station, receiving earth station, transmitting at the station and receiving at the station. Transmitting at the station sends signal to the satellite. Satellite receives the signal and performs some operations on that signal and collect the information in surroundings and send back to the earth receiver. Round trip delay is more. That is a propagation delay. In the system like satellite, the round trip time means send the signal from transmitter earth station to satellite and from satellite to receiver earth station. That is called as round trip time. It can be as long as 50 milliseconds. 50 milliseconds round trip delay, that is called as propagation delay. This will reduces the efficiency of the protocol. That is the reason we go for another technique. In case of stop and wait protocol, only one frame is sent. Only one frame is sent to satellite communication, receives that frame, perform the operations and send back to that receiver at the station. Some delay is there. Propagation delay, round trip delay is also there. That is the reason we go for another method to improve the efficiency, that is called as a protocol. That protocol, I have to introduce new protocol. That protocol is known as a go back N ARQ, has been developed. An improved protocol known as go back and ARQ has been developed. It is a method used to overcome the inefficiency of the stop and wait ARQ by following the transmitter to continue sending enough frames so that channel is kept busy while the transmitter waits for an acknowledgement. Inefficiency of that stop and wait protocol ARQ is eliminated by using go back and ARQ. Instead of sending one frame, multiple frames are sent at a time. After sending these multiple frames at a time from the transmitter, the transmitter waits for an acknowledgement. That is the important point. In this method, in this go back and ARQ method, one frame is damaged or lost. All frames are sent. All frames are sent since the last frame acknowledged or retransmitted. Last frame acknowledged. Suppose F0, F1, F2, and F3. These are the frames are sent from sender to receiver. This one sender to receiver. Check the validity of these frames at the receiver side. F0 is okay, F1 is okay, F2 is not okay. Therefore, NAC2 is sent. NAC2 means the second frame is indicated to the source is the second frame is damaged. Therefore, the source node sender or retransmits the frame from second frame. Again, send F2 and F3 also. Already F3 is sent due to second frame is corrupted. Some NAC2 received by the source node. Therefore, source node back to that second frame and also for consecutive frames sent to the receiver node. Second frame and consecutive frame is third frame. These two frames are sent. Therefore, two times received. F3 is 2 times. Go back n. Go back n means go back to n means here n is equal to 2. Here n is equal to 2. After go back n means n is equal to 2. From that second frame onwards, all consecutive frames are also transmitted from source node to destination node. F3 frame is reached to the receiver 2 times. One frame is discarded. That is called as go back and ARQ. Principle of go back and ARQ. Principle of go back and ARQ. This one is the transmitter side. Generally, go back and ARQ concept is totally based on sliding window protocol. Sliding window flow control method. This is the frame 1, 2, 3, 4, 5, 6. 7. Lateral I will explain 3, 4, 5, 6, 7, and 1. Suppose this is the receiver side. One, 2, 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, and 1. Here some delay is there. In live transmissions, from delay is there. Suppose in online classwork, I am at the transmitter, you are at the receiver. In real-time applications, I am delivering the lecture, but with some delay, that information is reached to you. That is the reason here delay is here, some delay. This one is second one, third one, fourth, fifth, sixth, seventh, third, here some 7 is there, 1 is there, like that. Okay. Here simultaneously send 7 frames to the, this one is transmitter, this one is receiver. Simultaneously send 7 frames. A window size is 7 frames. This one is window size is 7 frames. The 7 frames are simultaneously sent. The 7 frames are reached to receiver and stored at the receiver. Check the validity of these frames reached to receiver. First one is okay, second one is okay, but third one, some error detected. Some error detected. Some error is detected. Therefore, that error condition can come to the transmitter. Therefore, NAC3 is sent. That is NAC3. Whenever the NAC3 negative acknowledgement is reached to the transmitter thinking is the third frame is damaged. Therefore, transmitter go back to the third frame. Consecutive frames are also sent to the receiver along with that damaged frame. Consecutive frames means third frame is damaged frame from third frame, and 3, 4, 5, 6, 7. Again, from third frame to seventh frame, all these frames are sent. All these frames are sent and reach to receiver. From third to 7, again send frames to receiver from third frame to seventh frame. Okay. This damaged frame is reached. Okay, all right. But here 4, 5, 6, 7 already is there. Again 4, 5, 6, 7 is there. Therefore, these 4, 5, 6, 7 frames are discarded. These 4, 5, 6, 7 frames are discarded. Duplication is eliminated. This is the principle of go back and ARQ. Next one, go back and damaged data frame. First one is a go back. Go back means go back to the place where the frame is corrupted. Suppose third frame is corrupted, from that including that damaged frame and the consecutive frames already sent to that receiver. Also again send to receiver, including damaged frame. This is the go back and damaged data frame. Damaged data frame. This one is source, receiver. Link is created between source and receiver. Not simultaneous information. The source sender simultaneously, suppose 4 frames are sent simultaneously. 4 frames. 4 frames are simultaneously sent from source node to receiver node. This one is data. Data 0. 1. Data 1. Data 2. 5 frames, not 5 frames. Data 3. Data 4. 4 frames are simultaneously sent to the receiver, but error is occurred in second frame. This one, second frame. Error is due to damaged frame. Error is occurred in second frame. Error is occurred in second frame. Therefore, ACK2. This one is the ACK2 frame is sent to source node. Therefore, the source node go back to corrupted frame, that means data 2, and along with the data 2, consecutive frames are also sent to receiver. Consecutive frame here is only 3 and 4, and second data frame is also sent from source node to destination node. Therefore, after receiving this ACK2, the source node again send data to numbers are very, very important. Data 3, this is the frame numbers. Data 4. Data 4. These are the retransmitted. Retransmitted phase. Already second, third, fourth, all frames are reached to receiver, but second frame is damaged. Again, the second frame is sent, and again third frame is sent, and fourth frame is sent. Up to second frame is okay because some error is there, but the third and fourth frames are duplicated at the receiver side. Therefore, these duplicate frames are discarded. Discarded third and fourth frames. Discarded third and fourth frames. This is the go back and damaged data frame. Next one is second one is go back and last data frame. Go back and last data frame. Again, this one is the source node, receiver node. Four frames are simultaneously sent. Again, a link is created between source node and the receiver node. This one is data. Data 0. Data 1. Data 2. Last. Data 3. Data 4. In this case, data 2 is not reached. Data 2 is not reached. Therefore, from that data 2 is not reached, there is we can't perform any action at this point. Therefore, from this point, you have to send ACK2. This one is the ACK2. ACK2 is sent to the source node. Therefore, the source node think that the second frame is not the second frame is in error condition or in lost condition. Therefore, again, the source node send go back to that the source node go back to that second frame, and the consecutive frames are also included along with the second frame. Retransmit second, third, and fourth frames to the receiver. Retransmits the second frame. Second frame. Third frame. Fourth frame. Retransmitted. This one is the retransmission. Frames are received. Retransmission. Frames are received. Out of that one, second frame is okay. The remaining third and fourth, here third, fourth, these are the duplicate frames which are available at the receiver side, neglected, discarded. These are the two frames are discarded. Acknowledgement is lost sometimes. Go back in last ACK frame. Third one. Go back in last ACK frame. This one is a sender, receiver. A link is created between source and receiver. The sender send two data frames. This one is data 0, frame 0. Only two frames are sent from multiple. Means here two frames are sent from source node to destination node simultaneously. Okay, these two frames are successfully reached to a destination without any error. Therefore, the receiver node send ACK to the source node, but ACK2 is not reached last during the transmission. What happened? From this point to this point, consider from this point, and ACK2 must reach to this point. That means the timeout period. But ACK is not reached, but these two frames are successfully reached. These two frames are successfully reached. Therefore, again, go back and means go back. The source node go back and point 0 frame and first frame. These two frames are retransmitted. These two frames are retransmitted. It is data 0. Data 1. These two frames are retransmitted. Retransmission. These two frames are here. These two frames and these two frames, duplicate frames are reached. One set of duplicate frames are discarded. These two frames are discarded. Therefore, after discarding, Again send ACK to source node. This is the operations. Total operations related to go back and ARQ. ARQ means damaged frames are transmitted repeatedly. Damaged frame plus along with some consecutive frames are also sent from source node to destination node. Disadvantages of go backend. Disadvantages. Disadvantages of go backend. First one is it transmits all the frames if one frame is damaged or lost. Retransmissions are more and more. Therefore, throughput of the network decreases. Throughput means the number of transmitted frame per second is decreases because retransmit the damaged frame and also consecutive frames. If any frame is lost or damaged, that is the main disadvantage. It retransmits, it transmits all the frames if one frame is damaged, or lost. It transmits frames continuously as long as it does not receive the NAC signal. Simultaneously send, multiple frames are simultaneously sent. Therefore, up to it is not receive any NAC signal. It transmits frames continuously as long as it does not receive the NAC signal. The NAC signal takes some time to reach the sender. That is also drawback. The NAC signal takes some time to reach the sender. Till that time, the sender has already sent some frames. Before reaching that NAC, the sender sent so many frames. Suppose 10 frames are sent simultaneously. These frames are continuously reached to destination node. The second frame is damaged, suppose. The second frame is damaged. Again, send. Again, retransmit the frames from second frames to 10th frame. Second, third, fourth, fifth, sixth, 7, 8, 9, 10. Again, retransmit all the frames from second to 10. Waste, the bandwidth is wasted, time is also waste. Till that time, the sender has already sent some frames. Already sent some frames. All those will be retransmitted after receiving the NAC. All those will be retransmitted. Will be retransmitted after receiving the NAC. After receiving the NAC, negative acknowledgement. The error can get introduced. Sometimes NAC also has not reached. That is also drawback. The error can get introduced if the NAC is lost. The NAC is lost. Okay, these are the disadvantages. Disadvantage of go back in ARQ. Generally, go back in ARQ means sliding window flow control method. Sliding window flow control plus some errors identified. Some errors identified. What are the errors? Frame is lost, frame is damaged, acknowledgement is lost. These are the errors are identified, and make some transmissions simultaneously. Retransmit the damaged frames, lost frames, and so on. With this, the topic is completed. Go back and ARQ concept is completed. If you like this video, please subscribe the channel for further updates. Thank you.